You know, every single time you hop in your car, you're taking command of a machine that's locked in this epic, constant battle. Today, we're going to pull back the curtain on the heart of that machine, the powertrain, and its never-ending war with the laws of physics.
So let's just start with a really basic question. What does it actually take to get a 2-ton hunk of metal moving? It's something we do every day without a second thought, but the forces at play, they are absolutely incredible.
Well, the short answer is it takes a constant knockdown, drag-out fight against a whole bunch of invisible forces. They're all working together to try and keep that car right where it is. And the powertrain, that's your champion. Its entire job is to win that fight.
All right, so let's introduce the contenders. These are the invisible enemies your car is up against, basically fighting a three-front war every single time you drive.
Okay, enemy number one, rolling resistance. You know how when you squeeze a stress ball, it kind of takes a second to pop back into shape? Well, your tires are doing that constantly, thousands of times a minute, against the road. That constant squishing and unsquishing actually eats up energy that should be pushing you forward. And we're not talking about a tiny amount here. We're talking 4 to 7% of your car's total energy, just gone, poof. That's literally your gas money being spent just to fight your own tires. Next up, we've got aerodynamic drag. This one's pretty intuitive, right? Your car has to physically push air out of the way, but it's a double whammy. You get this high-pressure wall of air in front, pushing back, and at the same time a low-pressure vacuum behind the car that's kind of sucking you backward. Yeah, the air itself is basically trying to stop you. And the last enemy, well, it's one we all know and don't exactly love: gravity. Anytime you're going up a hill, a piece of your car's own weight is pulling you back down. Simple as that. Now sure, it helps you on the way down, but that climb, that's what engineers call grading resistance. So, for more than 100 years, what's been our weapon of choice in this fight? The good old internal combustion engine. But here's the thing, it's a powerful champion for sure, but it's got a very particular and kind of narrow fighting style.
It all comes down to this really cool process, the 4-stroke cycle. You can think of it like this: suck, squeeze, bang, blow. The engine sucks in air and fuel, squeezes it real tight, a spark makes it go bang, and then it blows out the exhaust. And this little dance, it's happening thousands of times every single minute. All those tiny, powerful explosions are what turn the wheels.
But, and this is a huge but, the engine has a weakness. It's only really, truly powerful and efficient in a super narrow range of speed. We call it the sweet spot. Outside of that perfect little window, like when you're stuck in stop-and-go traffic, its efficiency just tanks.
And that weakness, that narrow sweet spot, that's what cracked the door wide open for a new kid on the block, the electric motor. It's fighting the exact same invisible enemies, but man, it's got a totally different playbook and a serious competitive edge.
You feel the difference the second you touch the accelerator. A gas car has to kind of build up its power, you know? It needs to rev up. An electric motor? Nope. It gives you everything it's got, all its twisting force, its torque, the instant you ask for it. That's where that crazy, silent, push-you-back-in-your-seat acceleration comes from. And when we talk about efficiency, the difference is even bigger. Think of the gas engine's efficiency like a sharp mountain peak. It's great right at the very top, but it falls off fast on either side. The electric motor is more like a huge flat plateau. It stays super efficient almost no matter what you're doing. It just wastes way less energy, period. But honestly, the electric motor's real magic trick, its superpower, happens when you take your foot off the pedal. In your gas car, braking is just wasted energy that turns into heat. But an electric motor can run in reverse. It becomes a generator, and it uses the car's own forward momentum to actually put energy back into the battery. It turns braking into free fuel. How cool is that? Okay, so we've got the old champ with its flaws and the new challenger with all its strengths, so what if you made them team up? That's exactly what a hybrid is. It's not a compromise. It's a strategic alliance to get the absolute best of both worlds. First up, you've got the Series Hybrid. In this setup, the gas engine's job is totally different. Get this, it is never physically connected to the wheels. Its only job is to run at its one single most efficient speed, like a little power plant, just generating electricity for the motor. It's genius, really. The engine just sits there in its happy place, making juice. Then there's the parallel hybrid, which is the kind you see most often. Here, both the engine and the motor can drive the wheels, either working together for a power boost, or the motor can handle things by itself at low speeds. It's a simpler setup, but the trade-off is the engine can't always live in that perfect sweet spot, because its speed is tied to the wheels. So at the end of the day, whether we're talking about a pure EV or a clever hybrid,
all this incredible engineering, this whole battle with physics, it really all boils down to a few things that matter to you, the driver. Better efficiency, great performance, and above all, making sure you're safe.
So winning that war on fuel economy isn't about just one thing. It's a total strategy. You have to attack the resistance itself, using lighter materials and more slippery aerodynamic shapes. And you have to use these super smart drivetrains, hybrids and EVs, that don't just use energy better, they actually get some of it back.
But listen, being able to go is only half the story. All that power to fight physics is worthless if you can't control it. Being able to stop is arguably way more important. As this quote says, braking isn't just a feature, it is one of the absolute cornerstones of safety.
And here's a cool little piece of safety engineering that's baked into every car you've ever driven. Brakes are always designed so that the front wheels will lock up before the back wheels. Why? Well, if your back wheels lock up while the front ones are still steering, you're going to spin out. It's a simple but absolutely critical rule to keep you pointed in the right direction during a panic stop.
So we've gone from engines that just used brute force to fight physics to these incredibly intelligent systems that actually work with the laws of physics, even grabbing energy that used to just disappear into thin air as heat. It's been a total revolution. So it leaves you with one last question, right? Now that we're starting to get the hang of beating resistance, drag, and gravity, what's the next great challenge? What's the next invisible force that engineers will set their sights on?